Find the volume of the solid obtained by rotating the region bounded by y equals the square root of the natural log of x and the lines y equals 0, x equals 0, and y equals 1. This is going to be rotated about the x-axis. So we're going to need to draw the graph. Now this y equals natural log of x underneath a root is trouble. We generally don't have much of an idea of what it looks like, the graph of it, but we can make a guess and say that it likely looks like y equals natural log of x. We should recognize the domain of it, knowing that you can't take the square root of a negative number. Then the first value of x that you can plug into this function would be x equals 1, because that'll give you a 0. Natural log of 1 is 0. So anything larger than 1 is good. Anything smaller than 1 would be bad. And so x's need to be greater than or equal to 1. And as we said, when x is 1, y is 0. Another good number to pick for x is if x is e. Okay, the natural log of e is 1. And the square root of 1 will be 1. Alright, great. So when x is 1, y is 0. When x is e, y is 1. It's modeling the regular natural log. But let's see how long it takes before we can get to a y value of 2. Let's take the equation and set it equal to 2. Solve for x. First algebraic step would be to square both sides. Gets rid of the root on the right hand side and gives us a 4 on the left hand side. Now if we need to get inside this log, we're going to have to take and raise both sides as exponents on e. E to the left hand side is equal to e to the right hand side. Reason being is the cancellation works like this, where we end up with, yes, x is equal to e to the 4. E being about 3. 3 to the 4 is 81. So you're almost to 81 before the y value is 2. So it grows slower than a regular natural log would grow, but it has the same kind of shape, most likely. And so we'll just give it that, the x-axis is what we're rotating about, and we'll just give it that same kind of starting at 1, same kind of a look to the natural log of x, but it grows slower though. These other lines here are just the axes, right? Y equals 0, that's the x-axis. Okay, x equals 0, that's the y-axis. Y equals 1, that's the line there. And so we're talking about this region here. These guys intersect, remember, at e. Okay. Revolve this around the x-axis. We need to figure out what method to use. So we have a graph for each. On one we draw a rectangle that's parallel to the axis rotation. On the other we draw a rectangle that's perpendicular to the axis rotation. When you're parallel that shell, this rectangle gets moved upward. It's horizontal. It gets moved upward. And so that's in y. But when it comes to this vertical here, it's going to move to left and right. So we have to decide whether it's disk or washer. And everything looks fine as far as looking to be disk at first from 0 to 1. But when you get past 1 though, you're going to have a gap between the axis and the rectangle there. So it's like part disk and part washer. Disk between 0 and 1, washer from 1 to e. And this gets moved from left to right, so that's in x. Let's go ahead and set up the shell method. Now since the integral is in terms of y, then having this y equals natural log of x is doing us no good. So let's take and solve that for x. Square both sides. Get rid of the root. E to the left and E to the right, like we did before. And we get the cancellation here to get that x is e to the y squared. We're going to need the radius, we're going to need the height. Remember what the radius is. It comes from the rectangle to the axis. And it just so happens to be that in this particular example, this is the distance off of the x-axis. And that's called y. And there's nothing wrong with us leaving it as a y, since the integral is in terms of y. Now we have the height. Well, the height is the length of that rectangle, and it just so happens that will always be the distance off the y-axis, and that's going to be called x. But in this case, though, we can't leave it as x because we're in y, and it's the distance to the function here, so we'll have to say that the height will be e to the y squared. How about the limits? You're going to take this at a low point of 0 and move to a high point of 1. And so we can plug into the formula, and that's what we would need to integrate if we're doing it by shell. Just the nature of this second graph here being disk and washer would make me want to shy away from doing that. We could set it up, but I'm looking at this integral and I'm thinking that it's doable, although it looks very strange to have e to the y squared. With this y here, it actually saves you, and it looks like we can do this integral without too much trouble. So let's go ahead and work it out on the last slide. Step 3 is to perform the calculation. We have this exponent on e, which is 1 power higher than the power on the variable on the outside. So that's a clue that you should do u substitution. Let u be the entire exponent on e. Take the derivative. So if u is y squared, then du is twice y dy. Now you have to sub for y dy. So you're going to have to get rid of this 2 by dividing by it. Dividing both sides by 2, we just write this left-hand side as half of du, and the right-hand side is the y dy. Replace the y dy with half of du. Keep the 2 pi from the formula, and don't forget about the e. That now becomes e to the u. Your goal was to, in doing u substitution, is to get a much simpler integral, and now we have it. These 2's cancel out, and you're just looking at the integral of e to u times pi. Pi times that integral, and so the antiderivative is just e to the u. And so we're ready then to go back into our original problem with the y's and plug in 0 and 1. It just so happens that if you were to plug in 0 and 1 here, you'd actually get the right answer, but technically you're gonna have to do a limit switch if you're gonna do that. Anyway, so we go back into y's, and we 0 and 1. E to the y squared is the antiderivative, e to the u that is, and there's a pi out here. The 2 went away because of the half, so we put a 1 in and we put a 0 in, and our answer, e to the 0 is 1, so our answer is going to be e minus 1, that quantity times pi.